Determining incremental changes is another application of differentiation. Consider y, which is a function of x. The curve that you see in blue is how y relates to x. Now let's draw a tangent to this curve at point x. So the red line is a tangent to the curve y at a specific point x. Now let's consider an incremental change in x about the point x. So the incremental change in x will be denoted as delta x. And when x changes by an amount delta x, the y value changes by an amount delta y. So the vertical distance that we see here is the incremental change in y. Now we know that the derivative of y with respect to x is approximately equal to the incremental change in y with over the incremental change in x. In fact, dy dx is equal to the limit as delta x goes to 0 of the ratio delta y to delta x. Now if delta x is a small distance, then dy dx is approximately equal to the ratio of the incremental change in y over the incremental change in x. Now if we know the gradient of the tangent or the slope of the red line, then we know dy dx. Knowing dy dx and knowing delta x, using this relationship we can compute delta y. Let's look at an example. Example 16. If y is given by this expression, then find the incremental change in y if x changes from 1 to 1.001. So we'll start with finding dy dx. dy dx is equal to 4x cubed plus 6x squared plus 2x plus 1. So if we evaluate dy dx at x equal to 1, we will obtain the result answer of 13 by substituting x equal to 1 in this expression. Now dy dx evaluated at x equal to 1 is equal to the incremental change in y over incremental change in x. Now incremental change in x is 0.001 because x changes from 1 to 1.001. So we can now compute the incremental change in y because in this equation we know delta x and we know the ratio of delta y to delta x is 13. Hence we can compute delta y to be 13 times 0.001, which is 0.013. So let's look at another example, example 17. If the cost of producing X number of items is given by C, where C is equal to x on 10 minus square root x plus 10, then what is the incremental cost of producing one more item after producing the 50th item? That is, what is the incremental cost of producing the 51st item? So based on our discussion so far, we'll obtain dc dx. dc dx is the derivative of x on 10 is just 1 on 10. Derivative of square root x is half x raised to the power minus a half. Derivative of 10 is 0. So we know that dc dx is approximately equal to delta c, incremental change in cost, or incremental change in x. So incremental change in x is 1. It's the cost, incremental cost of producing the item 51 we are after. So DC is, delta C is what we are after, incremental change in cost. And we need to evaluate DC dx at x equal to 50. Because we are considering the incremental cost beyond the 50th item. So if we substitute 50 in this expression for dc dx, we'll obtain, so let's evaluate at x equal to 50. So we'll obtain 1 on 10 minus a half square root 50. So we can evaluate this number using a calculator. So dc dx is equal to delta c on delta x. So this, we've established this expression. So we can now say delta c on delta x is in fact this value we computed. And we know that delta x is equal to 1. So delta c is therefore, incremental cost is therefore given by this number, which we can evaluate using a calculator.